Good day to all our listeners, especially our BSIT second year, St. Anthony. So welcome to our lesson discussion proper about the review or chapter 1, review of, we have chapter 1, we have the review of linear equations and linear inequalities. So this is the first part of our chapter or first part of our subject, all about linear equations and linear inequalities. Why? Because this will be used for the chapter for the linear programming. So every one of us must be familiar with how could we find the value of x, or how can we determine the solution of a particular linear equations, as well as determine the solution set of a linear inequality. So, are you ready now? So, we may now start with our discussion proper. Okay, so by the way, I am Mr. Michael Flores, your instructor for today. So, for our first part, we have the linear equations in one variable. So what do you mean by a linear equation in one variable? So technically speaking, a linear equation in one variable can be written in the form ax plus b equals 0, where a and b are real numbers with a is not equal to 0. To solve an equation in this form is to find the value of the variable x that makes the statement true. So we have the following examples here. If you still remember your high school mathematics, so you already encountered examples such like this. So when we say a linear equation in one variable, we have one variable, specifically x, or you can use any variable, and it has no exponent. So meaning to say, it has only one as its exponent. That is why it's called a linear equation. And when we say this one, how can we solve for the value of x? So if you still remember your high school mathematics, we have basic methods by simply applying algebraic methods. So for example, we have for number 1, we have to solve for x. If we have 6x plus 4 is equals to 46, how can you find the value of x? So you have to transpose 4 to the right side, leaving only terms having the variable on the left side. So if you have 6x is equals to 46, since positive 4, you transpose it to the right side, it will become minus 4. Then you will have 6x is equals to 46 minus 4 is 42. And to eliminate 6, you have to divide both sides by 6. So applying the division property of equation. So canceling this one, meaning to say this one. So you'll have x is equals to 42 divided by 6 is 7. So the solution for our linear equation, 6x plus 4 is equals to 46 is 7. So if you want to check this, you may use the same value to the original equation. So we have 6x plus 4 is equals to 46. Substituting x by 7, so we have 6 times 7 plus 4 is equal to 46. And then multiplying 6 times 7, you will get 42 plus 4 is equals to 46. Then 42 plus 4 is 46 is equals to 46. Then the left and the right side are equal or the same. Therefore, our solution, which is 7, is correct. Okay, so I'm sure you have already remember this kind of examples during your high school and senior high mathematics. Okay? So proceeding to our next example, we have okay. So for our next example, we have example 2. We have 7x plus 4 is equals to 4 times the quantity x plus 7. Okay? So I'm sure you still remember how to solve this one. So applying the rule of PEMDAS, parentheses first, you have to remove the parentheses as much as possible. So you will have 7x plus 4 is equals to, distribute this one, we have 4x plus 4 times 7 is 28. Okay, then all the variables must be on the left side. So you will get 7x minus 4x, and we will have 28 minus 4. Okay, continuing our solution, 7x minus 4x, we will have 3x is equals to 24. Then to eliminate 3, we have to divide 3 both sides, applying this division property of equality. So cancel this one, so you'll get x is equals to 24 divided by 3 is 8. So our solution is 8 for the second example. So if we need to check, we'll apply checking by using the original equation, which is 7x plus 4 is equals to 4 times the quantity x plus 7. So from here, substitutes x by 8. Okay, plus 4 is equals to 4 times 8 plus 7. Okay, so from here, 7 times 8 would be 56 plus 4 is equals to 4 times 8 plus 7 would be 15. Then simplifying it further, we have 60 is equals to 4 times 15 is 60. So both sides are the same or equal. Therefore, our solution x is equals to 8 is correct. Okay? So this is how we solve for the value of x in a particular linear equation. Okay? So moving on our next example. So we have okay. So for our third example, we have example number 3. We have solve x plus, take note we have rational expressions in between the equation is equals to x over 3. So in this case, class, how can we solve for the value of x wherein we have denominators like this? So there are different ways or methods on how to solve, but one particular technique or clue is to eliminate the denominators first as much as possible as you can. Okay, so you can use the LCD method. Okay, so from here, rewriting our given equation, we have x plus the quantity 3 minus x all over 3 is equal to x over 3. Since we have 3 as our denominator and x has no denominator, understood it is over 1. So since we have 3, the least common denominator would be 3, so that would be our multiplier. Okay? So we will multiply the whole equation by the LCD, which is 3, and then you can now distribute to all our terms. So since we have 3 divided by 1 is 3 times x, that would be 3x. Okay? Then this one, you can cancel this because 3 divided by 3 is 1. So you have plus the quantity 3 minus x is equal to, cancel this one also. So you will only have x. Okay? And then, removing the parentheses, you will get 3x plus 3 minus x. So why is it minus x or negative x? Because positive times negative, that would be negative also, no? So is equal to x. Okay. And then all the variables or all the terms that have the same variables must be on the left side. So continuing this, you will get 3x minus x. So from here, we have x, transpose it on the left side, you will have also negative x is equals to positive 3, transpose it on the right, you will have negative 3. Okay? So we have 3x minus x minus x. That would be 3x minus 2x. So that is negative 3. So simply subtract similar terms. That means terms that having the same variable and same exponent. So 3x minus 2x, that would be 1x, or simply x is equals to negative 3. So this is now our solution for our linear equation. Okay? So if you'd like to check, okay, so for the checking, so checking is actually done or for the purpose of checking if your solution is correct. So using the original equation we have from here, we have x plus 3 minus x all over 3, that would be equal to x over 3. So substituting or replacing x by negative 3, so you will get negative 3 plus the quantity 3. We'll be using a bracket here, 3 minus the quantity negative 3. Okay. Parentheses all over 3 is equals to negative 3 over 3. Okay? So from here, simplifying it further, we have negative 3 plus, we have 3 plus negative times negative, that would be positive. 3 plus 3 all over 3 is equal to negative 3 divided by positive 3, that would be negative 1. So simplifying it further, you will have negative 3 plus 3 plus 3, that would be 6 over 3 is equals to negative 1. So we have negative 3 plus 6 divided by 3 is 2 is equals to negative 1. Then negative 3 plus 2, that is negative 1, is equal to negative 1. That means our solution, which is negative 3, is correct. So that's how simple, how can we compute for the solution or the value of x given a linear equations. Okay, so any question in class for this particular example? Okay, so if none, you can now proceed with the other examples. Okay, so from here we have an exercises. Okay, so exercise 1, solve the following equations. I'm sure you already know how to compute or to solve for this. Sometimes if you're good enough with mathematics, some simple linear equations can be solved mentally. Okay, so for this particular set of exercises, maybe probably I will select only few of them, especially those who seems to be difficult. Okay, so let's try. Okay, the first equation. So for number 1, okay, so we have 7x plus 8 is equals to 1. Okay, what is the value of x? So we have 7x is equals to 1 minus 8, transpose 8, so you will get 7x is equals to 1 minus 8, that would be negative 7, dividing both sides by 7. Cancel this or simplify, so we have x is equals to negative 7 divided by 7, that would be negative 1. So this would be our solution. Okay? So for the checking, I usually encourage students to do the checking so that they will have the feeling of satisfaction while they are solving, so that they whenever they want to proceed, they are confident enough to themselves that their answers are correct. Okay, so for this we have to substitute 7x plus 8 is equals to 1. So we have 7 multiplied to negative 1 plus 8 is equals to 1. 7 times negative 1, that would be negative 7 plus 8 is equals to 1. The negative 7 plus 8, that is positive 1, is equals to positive 1. Okay? So by the rule, a negative and a positive integer added together, their sum would be the difference between the two, copying the sign of the bigger absolute value. Okay? So, any question? None. Okay. So proceeding with our second example for number 2. Okay, so we have 9 minus 2x is equals to 15. Okay? So, retaining 2x or negative 2x, that is equals to 15. Transpose 9 to the right side, that would be negative 9. So we have negative 2x is equals to 15 minus 9, that would be positive 6. Dividing both sides by negative 2. Okay, cancel. So you will get x is equals to negative 3. Because 6 divided by negative 2, that is negative 3. So this is our solution. Then for the checking, we have 9 minus 2x is equals to 15. So we have 9 minus 2 times negative 3 is equals to 15. So we have 9. Negative 2 times negative 3, that would be positive 6. So summing it up, you will get 15 is equals to 15. Therefore, our solution is correct. Okay? So we will select some. So for number 3 and number 4, I'm sure you can solve those. Okay? So I'll be moving on example number 5. Okay? So for example number 5, we have 3x over 4 plus 5x over 2 is equals to 13. Okay? So for this example, you will observe that we have rational expressions which have different denominators. Okay? So to eliminate this denominator, we can use the least common denominator or simply the LCD. So for this, the least common denominator would be positive 4. Okay? So with this, we have 3x over 4 plus 5x over 2 is equals to 13. Multiplying the whole equation by the LCD, which is 4, and you can now distribute them to all our terms. Okay? So since 4 divided by 4 is 1, so 1 times 3x, that would be 3x. 4 divided by 2, that would be 2. Times 5x, that would be plus 10x. And then 4, understood this is over 1. 4 times 13, that would be 52. Okay? So simplifying it further, 3x plus 10x, that would be 13x is equals to 52. To eliminate 13, divide both sides by 13, applying the division property of equality. So 13 divided by 13 is 1, so you will have x is equals to 52 divided by 13, that would be positive 4. So our solution for this equation is positive 4. Okay? Then for the checking, so we have 3x plus 5x, 3x over 4 plus 5x over 2 is equals to 13. Okay. Substitute x by positive 4. Okay. 5 times positive 4 over 2 is equals to 13. And simplifying it further, we have 3 times 4, that is 12 over 4, plus 5 times 4, that would be 20 over 2, is equals to 13. So 12 divided by 4, that would be 3, plus 20 divided by 2, that would be 10, is equals to 13. Okay? So we can now have 3 plus 10, that is 13, is equals to 13. Okay? So that's how simple it is to solve for the value of our solution, or solving linear equations in one variable. Okay? So we have another one. Okay. So number 6, you like to solve number 6? Okay. Okay. So for number 6, we have 3 times the quantity x plus 2 is equals to 5 times the quantity x minus 6. Okay? So, applying the rule of PEMDAS, we can also multiply our common monomial factor outside to all the terms inside to remove the parentheses. So from here, 3 times x, that would be 3x, plus 3 times 2 is 6, 5 times x, that would be 5x, then 5 times negative 6, that is negative 30. Okay? Then, putting our variables on the left side, we will have 3x minus 5x. Then we have negative 30. Transpose positive 6, we will have negative 6 on the right side. Then 3x minus 5x, since we have think positive 3 minus positive minus 5, that would be negative 2x is equals to negative 30 minus 6, that would be negative 36. Okay, if they have the same sign, copy them or add them. So to eliminate negative 2, we have to divide both sides by negative 2. Okay, cancel this one, then you will get x is equals to negative 36 divided by negative 2, that would be positive 18. Okay, kindly check. Negative divide negative, that would be positive. Okay, so for the checking, we have 3 times the quantity x plus 2 is equals to 5 times x minus 6. Okay, so for this, we have to substitute x by 18 plus 2 is equals to 5 times 18 minus 6. Okay, so simplifying it further, we have 3 times 18 plus 2, that would be 20. Then we have 5. 18 minus 6, that would be 12. So 3 times 20, that is 60. Then 5 times 12, that is also 60. Okay, so this is our checking, and our solution is 80. Okay, so any question, class? None. Okay, so we have another set of examples here for exercises. Okay, so for this, we have, okay, so we will select some among these. So from our given, okay, so let's try number 7. So this is one of the common linear equations. we have the quantity x minus 2 all over 3 plus 1 is equals to x over 7. So for this particular linear equation, one thing that you have to consider is the denominator. And since it has different denominators, we can determine first the least common denominator. So since we have positive 1 here, understood it is over 1. So 3, 1, and 7, what would be our LCD? So if you cannot determine a particular LCD, just simply multiply the denominators itself. So by this, we have 21 as our least common denominator. Okay, so this would be our multiplier for the equation. Then we have x minus 2 all over 3 plus 1 is equal to x over 7. So from here, we have to multiply the whole equation by the least common denominator, which is 21. So 21 divided by 3, that would be 7. So we have 7 times the quantity x minus 2 plus 21 times 1, that would be 21. Then 21 divided by 7, that would be 3 times x, that would be 3x. And then remove the parentheses here. So we have 7x minus 14 plus 21 is equal to 3x. Simplifying it further, we'll have 7x minus 3x. Transpose 3x from the right side going to the left side. And then negative 14 plus 21, that is positive 7. Then transpose it, you will have negative 7 here. So we have 7x minus 3x, we have 4x is equal to negative 7. And then from here we have we divide both sides by 4, leaving x is equal to negative 7 over 4. This would be our solution. So it's not a guarantee that all our solution is a positive or is a whole number. So in this particular example, we got a negative value or a negative fraction form. Okay? So for the checking, so we have, so for the checking, this should be one of the bloody checking that we will encounter. So replace x by negative 7 over 4. So we have negative 7 over 4 minus 2 all over 3 plus 1 equals negative 7 over 4 all over 7. Okay? One of the common mistakes my students always ask or encounter is having the similar fractions. Okay? So in this, or having rational expressions like this. So for this, you can apply the rule for determining the similar fractions or determining the same denominator. So for this, we could have 4 as our LCD. So we have negative 7. So this is understood over 1. 4 divided by 1, that is 4, times negative 2, that is negative 8. All over 3 plus 1 is equal to negative 7 over 4. Okay. Multiply to the reciprocal of 7. So that would be 1 over 7. Okay. And then this one, proceeding, we have negative 7 plus minus 8. That's negative 15 all over 4 all over 3 plus 1. Okay. Is equal to, cancel this one, multiply. So we have negative 1/4. Okay. And then from here, we have negative 15 over 4 multiplied to the reciprocal of 3, which is 1/3, plus 1. We have negative 1/4. Okay? Then, cancel this. We have negative 5. Negative 5 times 1, so we have negative 5 over 4 plus 1 is equal to negative 1/4. Okay? By LCD, we have 4. Negative 5 plus 4 is equal to negative 1/4. Simplifying it further, we have negative 1/4 is equal to negative 1/4. So, we have a correct value or solution. Okay? So, any question for this? None. So, I think this is enough already for you to have practice for the linear equations in one variable. So, kindly take a photo of the example here or the exercises. That would be your activity. And then the last part, we have this. Kindly take a photo of the following given numbers: 11, 12, 13, 14, and 15. So for your activity, answer or find the value of x or solve for the following linear equations numbers: 11, 12, 13, 14, and 15. Okay? So with that, thank you for watching, and I hope you learned a lot about simple linear equations in one variable. And this is your mathematics guide, Mr. Michael Flores. Happy to teach you. Goodbye and God bless.